Hello everyone, welcome to AWS Tutorials. In AWS Tutorials, you'll learn about AWS services. First of all, Happy New Year to everyone and hope everyone enjoyed their holiday period. Let's start this new year with a very exciting topic about how to handle transaction in ETL glue jobs using AWS Lake Formation. So first I'm going to talk about the whole concept and then I have a demo towards the end of the presentation. So let's get started. Let's first try to understand what we are trying to solve over here. Suppose you have a data platform where you use AWS Glue job to bring data from different type of database to a central platform, and then you use that platform for your different use cases, for reports, dashboards, or any kind of machine learning. So suppose this Glue job actually reads data from a table from the database, then it creates two different transformation on the data. It suppose selects certain columns and rows to create one set of data and write that into an S3 bucket. Then it creates another set of rows and column and writes that data in another S3 bucket. And then it's simply cataloging both of the data in two different S3 location. So suppose this is what a glue job does. This could be a very typical glue job you will come across in your day-to-day implementation. In this whole glue job implementation, our purpose is to make these four operations transactionals. So basically what this glue job is doing, it's reading data from a table in the database, then it's creating two formats of the data or two transformations on the data, that's writing that to two different S3 locations and then simply cataloging data on those locations. So basically it's storing data in these two locations, then it's cataloging data in their respective locations, and these four operations we want to do like a transaction. That means either all four operations should be performed correctly and successfully, or if any of the operations fails, all four operations should roll back. So there should not be any partial thing like out of four only two got successful, two failed, or three got successful, one failed. Either all four operations should succeed or all four should roll back or cancel out. And the four operations I'm talking here in this example is writing data to two different S3 locations and then cataloging them. Okay, so that's what we are trying to solve here. We're trying to implement a transactional behavior in a AWS Glue job. And let's understand how we can do that. In order to do that, you have to understand a new concept which has been introduced into AWS Glue, and that is called governed table. So when you're trying to catalog your data into Glue catalog table, there are two types of table you create. All the tables you have created previously, they are all called non-governed table. Okay, those tables are called non-governed tables. And now during the reInvent time, they announced the general availability of the governed table. And now a new type of table which has come into Glue data catalog tables, and that is called governed table. Governed tables are tables which are managed by AWS, and it provides many features, including support for the transaction. So this whole transactional behavior is possible because AWS Glue now supports a new type of table, and those tables are called governed table. You can still create like old tables which you used to catalog, and those tables are non-governed table. You can still create them, still use them. There is no change in that. But a new type of table which has come, you can create now, and those are governed table. And these governed table has certain new features. So these tables are managed by AWS. The first set of features available in the governed tables, it supports ACID transaction. So it supports transactional behavior in ETL Glue jobs, and if multiple simultaneous query or update operations are happening on your data, then it provides ACID transactional behavior on the data query and data update. That's the first feature which Govern table provides. The second feature is it does automatic data compaction. Now, if we have learned about how to enhance the performance of the query, for the objects stored into S3 bucket, you must have learned that if S3 objects are very small, it impacts your performance query. So what Govern table do, that it automatically does data compaction. That means it automatically compacts your small data objects into larger object, so that it enhances the overall query performance. So that's the second feature this Govern table provides. And the third table, which is very interesting one, and that one is you can make a time travel query. And what exactly mean by that is, suppose if I want to know that on the 31st of December, 12 o'clock during the day, 12 p.m. I mean, what was my data? What was my data on 31st of December, 12 p.m.? I can make query like that. I can know the state of the data for one of the previous date and time. So you can really create a snapshot of the data for a particular date and time. Now, to be honest, each of these topics need a separate discussion, and as I come across different type of use cases, I will make more videos. But today I want to focus on the transactional support in the ETL glue job, and we'll try to solve the problem like the example I showed you in one of the first slides. So keep this in mind. If you want to avail transactional behavior in your ETL glue job, then you need to work with Govern table. Okay. So let's try to understand through one comparison that what exactly is this transaction in ETL glue job, because so far we have heard about transactional behavior in databases. So we'll try to compare the transactional behavior between database and ETL glue job, so that you get some clarity that when you say a transactional behavior inside the ETL glue job, what exactly it means. So let's compare a database transaction with an ETL transaction, so that you can find some mapping between them and help you understand what transaction I'm talking over here. So talking about a database transaction, when you're trying to do a database transaction, you generally start a transaction, then you make a database connection using that transaction, then you perform different type of CRUD operation. This could be like insert a record, update a record, delete a record. Those kind of multiple operations you can perform across different tables under the context of this transaction you can perform. And finally, you see that if any point of time, if any error come, then simply roll back the transaction, so all the CRUD operations simply roll back. They don't really happen. And if no error come, then simply you commit the transaction. So that's how a typical database transaction operation you perform. Let's now try to compare that with an ETL transaction. So in case of ETL transaction, you simply start a transaction, then you fetch data from the source. So it's a ETL, it's a extract, transform, and load. So you are extracting data from the source. Then you do transformation. So you perform different types of transformation. Now you can do a single transformation, 10 different types of transformation. From one load, you can create multiple small data frames or multiple different data formats, or you can simply have a single transformation. You can do that as well. So you perform transformation on your data. Then you simply write that data to the target using the transaction. Okay. So just like in database, you have a CRUD operation where you simply create, update, or delete. Basically, you yeah, you can do read as well, but you create, update, delete are the main transactional operations. Similarly, here in case of ETL glue job, you also write your data to the target, then you update the data catalog schema. Both of these two things you do under one transaction. And finally, you in this whole operation, in this whole ETL job, if any error comes, you simply cancel the transaction, and when you cancel the transaction, any of the changes you have made, whether you have updated a catalog table, a schema, or you have written some data into some location, any of those changes get cancelled, gets rolled back. And if no error comes, then you simply say commit transaction. In that case, all the operations are committed and confirmed. So I try to show you a comparison between a database transaction and ETL transaction so that you can relate and get your head around that what exactly transaction we are talking about from the ETL point of view. So in ETL, basically you make two different types of CRUD operation. If you try to use the CRUD as a way of defining it, one is you write some data at your target location, and second is you update the catalog of the catalog schema of the data. Okay, and we want this writing to the target, this updating of the data table catalog, both to be a transactional behavior in the ETL glue job. Okay, so we all understand now the concept of transaction, and I will show you very soon how you can do that. But the very first thing which comes to mind is that the transactional behaviors can be done only on the governed table. So let's try to understand how you can create a governed table. Now, there are a couple of things which are very important. Governed tables have a lot of if and buts. I will say simply go and search, look into AWS documentation. But three very important things which I want to share over here. First is governed tables are manually created. So you cannot use a crawler to create a catalog a table. So if you want to catalog a governed table, you have to manually create it. You cannot use crawler. That's the first thing. Right now, the governed tables are supported only for data stored in Amazon S3 bucket. You know that in a data platform, you can have data into S3 bucket, Redshift, RDS, JDBC endpoints, RDS. Yeah, your data could be in DynamoDB, DocumentDB. I mean, yeah, many sources, and each of these locations can be actually cataloged. But when we talk about governed table cataloging, the governed table works only with S3 as the data location. So if you're trying to use a governed table with other than S3 location like Redshift or RDS, that is not supported, at least at this point of time. Okay, it's not supported. Last one, when you are trying to use a governed table, you must register the S3 location into Lake Formation. So I will show you a demo as well. So when you try to create a governed table, since data is stored into an S3 bucket, that S3 bucket location should be registered as a data location in your Lake Formations. So these three are very important for you to understand from the governed table point of view. By the way, keep this in mind that crawler cannot create the governed table, but API can create the governed table. So if you want to automate, you still have a choice to use a Lake Formation API to create a governed table. So APIs you can use, but crawler you cannot use. And other than these three, actually your governed tables are similar to any previous classical table you have been creating. Only a new option you see when you try to create a table is says, hey, do you want to enable governed data access and management? And when you do that, your table converts into a governed table. It's as simple as that. So you cannot convert an existing table into governed table. You can only create a new governed table. And when you try to create a new governed table, you need to tick off this checkbox, and then by checking that box, you're saying that this table is a governed table, and you can do it only manually all through APIs. So, and I'm going to show you how to create govern table, so don't worry. I mean, yeah, you will see that in demo as well. Now, when you're trying to work with govern table, there are certain roles and certain permissions which are very important, and that's why I want to give you some idea around that, so that there's a documentation available, but it's little scattered, and I thought if I put everything together, then it will be very useful for you. So there are certain roles and permissions which are very important. So first role is your data location role. So when you create a data location, you have to give certain role permission on the data location, and basically this role is used by Lake Formation to access data location and handle the transaction. So you need to create a role for data location role in Lake Formation. So it's a Lake Formation based role. Then you create glue jobs. So you create glue jobs which are simply doing the ETL operation, like the example I showed you, reading data from database, then writing to a govern table and handling the transaction. That is done by a glue job, and this glue job also needs access to data location and handle transaction. So for that, you need to create an IAM role for the glue job. Then there will be end users who will like to query data from query data in Lake Formation using Athena. So basically, you want to use Athena to access data from your governed table, and you need certain access permission for that. And similarly, there will be administrator who will be performing the administrator task within Lake Formation for the governed table, and for that also you need certain level of permission. So these four roles and permissions are very important, and in next couple of slides I'm going to talk about what permissions these roles should have. Let's start with the data location role, and this data location role is actually an IAM role, which has a trust relationship with Lake Formation. So it is a trusted role for AWS Lake Formation, and this role is used by Lake Formation to access your data location and manage the transaction, like the rollback behavior, commit behavior, to manage those kind of behavior. So what permission this data location should have, data location role should have? It should have two permissions. So one permission is on the data location itself. So you can see here, it's giving put object, get object, delete object permission on the data lake bucket. So this is the bucket which is used by your data in the Lake Formation. Or you can say, in other words, this is where your S3 based data, this is the S3 location where your data is stored. So you can see in that bucket, for all the objects, you need to have put, get, and delete permission, because you write data, you fetch data information, and you also delete in order to manage the whole transaction, and you also need to have a list location on the data bucket. So that's the S3 permission. And then other than that, you also need permission on Lake Formation, and in Lake Formation you need to have permission to start transaction, commit transaction, cancel transaction, get table object, and update table object. So these 5 permissions you need. So you might want to create a policy with these, like one policy for S3 location, one policy for Lake Formation, and using these 2 policies you can define the permission for your data location role. Now the next one is your glue job, and glue job role is the role which AWS glue job will use when running the ETL operation. So this is a role which creates a trust with glue service, and this role will have the following permissions. So first of all, it will have certain AWS managed service permission. So managed services permission it will have is glue service role, AWS Lake Formation data admin, and if you are trying to work with Kinesis for streaming data handling using Glue job, then you also need Amazon Kinesis read-only access. If you're not working with Kinesis for any kind of streaming data job, then you don't need this third one, but first two you definitely need. Then similar to the earlier data location role, you also need to, this Glue job needs to have access to your S3 bucket. So this is your S3 bucket where your data is stored, and you need to have put, get, delete, and also your list bucket operation. And then the last one, it also needs to have Lake Formation API access. So for instance, it can do start, commit transaction, it can extend the transaction, it can describe the transaction, so it can fetch the status of the transaction, it can list the transaction, and it can also update the table object. Okay, it can update the table objects. So these are things which a Glue job role should have as a permission in order to work with govern table to handle the transaction. Similarly, end user permissions. So the end users which is trying to use Athena to query the data, what policy this end user should have. It's pretty straightforward. The end user should have Amazon Athena full access, first of all, and then it should have certain Lake Formation permissions. So it can basically it has query permissions, it has transaction permissions, so those kind of things it can do. So if you provide this managed policy and this custom policy, if you provide these two set of rules or permissions to the end user can use Athena to query the data from the govern table. And finally, from the admin point of view, the admin users who has to administrate the Lake Formation, that person should also have these transactions and objects and query related permissions. Plus, it should also have IAM read-only access, Amazon Athena full access, and Lake Formation data admin. So as long as these permissions the user has, the user can administrate the Lake Formation, govern tables, and also, of course, transaction related things. So it is very important that we understand these 4 different types of permissions which different roles our users might have in order to work with govern tables within the Lake Formations. Okay, so let's get started. So moving on to the data access control in govern table. So now we all know that in Lake Formation we don't give IAM like if you're using Lake Formation security, then you don't use IAM based access policy. I mean, you might have certain policies from the Glue or Lake Formation point of view, but that does not give you permission to any data, any table. And if you look at the permissions I showed and talked about earlier, it simply gives permission from the service point of view. It is not giving permission to any table, any column. The reason being, govern table uses Lake Formation based security. It's as simple as that. It uses Lake Formation based security. So in govern table, similar to classical table, you provide a user or a role access to tables for select operation, insert operation, delete, describe, drop, those kind of operations. The similar to classical tables permission you used to give in Lake Formation, govern table also uses the same format. So the earlier permission I showed you, those permissions simply give permission at the service level so that you can handle transaction, you can access metadata of the table and those kind of things, but they don't give access to table itself, like data at the table itself. In order to give access to data at the table, you have to use Lake Formation security to give those roles, those users, access to a particular table, or if you want to restrict access to particular to set of rows or set of columns, all those things you can do using Lake Formation security. So that fundamental does not change. You still use data access control within Lake Formation to access data even with the governed table. So let's move on. And if you're trying to access data using Athena, this is very important. Because then you have to create a particular special work group, and that work group will have name called Amazon Athena Lake Formation. So generally, Athena has its own by default work group, and if you try to use that by default work group to access data from your data lake, you cannot do that. It will not work. You have to use a special a special Amazon Athena Lake Formation work group using the latest Athena engine to access the data. And with this work group, you can also make those timestamp based query on your data, where you can actually take a snapshot of the data for a particular time, date and time in the past. Okay. So how do I handle transactions? So now that we have understood the concept of governed tables and permissions and how to access the data, query the data, all those things are done. So those are the fundamentals. I mean, you cannot do transactions unless you understand those fundamentals. So now coming back to the key point today, that how do I handle transactions? What are the methods available within AWS Glue job to handle the transactions? So there are basically three methods available. You can use AWS Data Wrangler. So if you look at the latest version of AWS Data Wrangler, it now has got APIs for Lake Formation governed table, and using those APIs, you can not only create and maintain your governed table, but you can also handle your transaction. Other than that, you can also use Lake Formation Boto 3. So I'm using Python as an example here. So you can use Lake Formation Boto 3 Python library to handle the transaction. And you can also use PySpark in Glue job to handle the transaction. So there are basically three primary methods you can use to handle your transaction. Now, AWS Data Wrangler, if you go and search about that, it's very well documented with a lot of examples. So that I'm not going to cover today. So primarily, I am going to cover two methods today. One is using Lake Formation Boto 3 to handle the transaction, and second is using PySpark in Glue job to handle the transactions. So let's move on. So let's first talk about Lake Formation Boto 3 to handle transaction. Now, why I'm talking about Lake Formation Boto 3 as a first example, because the PySpark libraries has been extended to support transaction, but those libraries end of day use Lake Formation Boto 3 APIs to handle transactions. So you basically make call to PySpark APIs, Glue context, those objects, those constructs, but then they in reverse make call to Lake Formation API. So I thought let's talk about first Lake Formation API level things, and then I can then when I talk about the PySpark, you will understand what those PySpark API should be calling behind the scene to make this whole transaction work. So let's take example. If I have to handle a transaction using Lake Formation Boto 3, I'm taking Python as an example over here. How do I do that? So first you start the transaction. So first step is start transaction. So you simply say import Boto 3. Let's create a client, Boto 3 client, Lake Formation. Let's get a Lake Formation client. And then you simply say client.start transaction. And this transaction type could be read and write. So read you want to use if you want to simply read the data. You want to have a consistent read of the data, then you can use a read. But if you want to read and write both, like you're doing a typical ETL operation, so you want to read and then write, then you simply select transaction type as read and write. And then once this transaction is started, you fetch the transaction ID, because this transaction ID now you have to use as a way to manage all the operations under a single transaction. So first step is to start the transaction. Then you perform ETL operation. So now in this case, like you can perform ETL operation in many ways, but the way I am telling here that to perform the ETL operation is by simply copying the data. So what I've got here is that I'm creating a S3 client, and then I'm saying that I have some bucket and source folder and object name. I want to simply copy data from there, and I want to copy it to some bucket, some destination folder and object. So I'm simply taking data from one S3 location and copying to another S3 location. And that's the example I have taken here over here. You could have use some other method to perform the ETL. So I'm not doing any transformation here. What I'm doing is simply loading here. So I'm reading data from one S3 location and writing to another S3 location, and the target S3 location is where my govern table is. So my govern table is configured for my destination folder location. So I'm going to show you demo as well, guys, then it will make more sense, but let's try to understand the code first. So I'm simply performing a ETL of the data here. Now, the step number 3 is that you have to mark your object for deletion on transaction fail. Now, you said that I'm copying my data to the destination location. Now, you want to simply want to mark those objects. So just look at this bucket, destination folder, this object, and it has got an E tag, okay, entity tag. This object I have written at the destination in the step number 2. Now I'm simply saying that this object I'm marking for deletion. So to delete the object on cancellation of my transaction. So that's what I'm trying to tell. So delete the object on cancellation of my transaction. So this is the object which should be deleted if transaction fails. This is my table name at the target. This is my database name at the target. This is my account number, and here I pass my transaction ID. So remember, I started a transaction and fetched a transaction ID. I'm simply passing the transaction ID. So now I'm saying that under this transaction, if this transaction fails, then simply the object should be deleted. Now it has been written in step number 2. In step number 2, I have written my data, but if my transaction at any point of time here onwards fails, simply delete this particular object. And then comes your step number 4. Now that you have written your data at the target, now you want to update the object, because update the table object. So the data which is written at the S3 location, that is cataloged as a table in a database. So we simply call a method called update table object, and then update in this database this particular table under this transaction ID, and these are the objects which I have written, and it's the same thing, bucket, destination, object, E tag and size, entity tag and size. So these are the objects I have written at the destination, and simply update this table for these new objects added. So I'm simply updating the catalog with the new object added to the table location, and this also I'm doing under transaction, and everywhere we are passing this transaction is a way transaction is as a parameter, because at any point of time if my transaction fail, like in this case, if my transaction fail, I want my data to be deleted like I showed in step number 3, and I also want my object changes to be rolled back as I'm showing here on the step number 4. So remember, the ETL job, you have 2 tasks. One is you're writing the data, and second you're updating the catalog. So both writing the data and updating the catalog I have marked with transaction, so that if this transaction fails at any point of time, you simply roll back these 2 operations. That means delete the data from my destination, and also roll back any changes which has happened to my table object. And after that, guys, it's pretty straightforward. You simply put a nice try and except block saying that go for commit transaction. If any error comes, go for cancellation of the transaction, and simply pass this transaction ID as parameter there. So what basically this code is doing is that it is simply starting a transaction, then writing a data at the destination, then marking the data for deletion on the cancellation of transaction. Then you are updating the catalog table again under the transaction, and finally you're trying to commit the transaction. At any point of time, if exception comes, then your cancel transactions will be called, and when the cancel transaction is called, it's simply going to roll back the update behavior. It's going to roll back the data write which has happened. So that's how the API in Lake Formation works. I'm going to show you a demo and then start making more sense, because then I can show you the API running and data being written and then getting rolled back. I'm going to show you all those behaviors. But these are the APIs which are like, even if you use the PySpark, glue job, they are going to basically in reverse call these APIs to get the transaction done. So I thought let's talk about these APIs first, so that you have understanding about how Lake Formation works, and then we'll try to understand how my glue job works. So let's move on to the next part, which is if I'm trying to do the similar thing, what I did right now, if I'm trying to do the similar things using a PySpark based glue job, how does that work? Now it works in a similar way. So like a typical glue job, here I'm starting a typical glue job. I'm getting my arguments, I'm creating my Spark context, and I'm creating my glue context. I'm getting my session information, and then I'm simply using this glue context. I'm simply starting my transaction, and here it says read only as a parameter. So if read only is true, means I'm only reading, but if read only is false, that means I'm reading and writing both. Now here the glue context has been extended to have a new method called start transaction, which I can use to simply start the transaction. But in reverse, this start transaction actually calls Lake Formation APIs to start the transaction. So that's why I showed you Lake Formation APIs first. So you simply start a transaction and you get back a transaction ID, which you are going to use in the glue job at the other places. Now I'm performing the next operation, which is nothing but simply basically ET, not load, but ET my data. I'm not doing ETL here, but ET my data, extract and transform my data. So you can see over here that I have created, I'm using this glue context, create dynamic frame from catalog, from this database, this table, create this data frame, and then on that data frame I'm performing simple transformations, select only these two fields, order number and sales, and populate that back to my data frame. So you can see here my extraction and transformation operations, there is no change. I have fetched my data from my source location, and I have also performed transformation. Now it is time to write the data. So write the data and update the catalog with the transaction. And for that purpose, here is my destination path. So here is my destination path where I am writing my data in the S3. So we create a sink first. So we use glue context get sink. This is a S3 type of location, S3 type of connection. This is my location. I want to update my catalog. So when I'm writing my data there, I want to update my catalog that a new object has been written at your data location. I want to register that new object in the catalog. So I want to update my catalog. I'm passing transaction because I want to perform this operation under one transaction, under a single transaction. And then I'm simply saying that as additional option that call delete object on cancel equal to true. That means if at any point of time transaction fails, roll back to delete my object. So that means whatever data I am going to write using this sink, that data should be rolled back. That should be cancelled out. And of course, it will also cancel out my updating my catalog. So you had in Lake Formation, you call two different APIs to do that. Here in a single method get sync, I'm simply saying enable my catalog update, and also delete my object if my transaction cancels equal to true. Then I simply set my format, which is I'm using parking in this case, and I say, okay, what location you need to update. So I'm saying in my database, I have this customers governed table. Simply you need to update that table. So now I have defined my sync location, and this sync location I have simply bundled with or associated with a transaction, so that if this transaction at any point of time fails, it will simply roll back the catalog update as well as data write operation. So now we move on and we do a simple commit or cancel a transaction. So we simply say sync write frame, simply write this data dynamic frame, over here, and simply commit the transaction. At if any point of time, if any exception comes, then you simply cancel the transaction and you simply commit the job. So job finishes. So it's pretty straightforward. If no error comes, it will come to the commit and it will be over. But if any point of time any error comes, then it will cancel the transaction. And when it cancels the transaction, it's going to roll back the data object it has written at the destination. And it also going to roll back any kind of catalog change which has happened in my govern table schema. Okay, so pretty straightforward, and these APIs basically behind the scene call Lake Formation API to perform the task. So time for, okay, one more thing before we go for demo. So sometime you use glue job with VPC. So what happens, sometime you're writing a glue job when you use a glue connection, whether you're using a glue connection to talk to an API or a database, then in that case, your glue job runs in a VPC, okay? So if you're using a glue job with a glue connection, it runs in a VPC. And glue job needs access to Lake Formation API to manage the transaction. But once it runs inside a VPC, and if VPC does not have NAT gateway or Lake Formation VPC endpoint, then your glue job actually cannot access Lake Formation APIs. So keep this in mind, guys, and this is very important, otherwise you will face a lot of error, that if you're creating a glue job which is running with a glue connection, that means it's running inside a VPC, then you should either have the subnet associated with a NAT gateway, or to be more secure here, you should configure Lake Formation VPC endpoint for that particular subnet in the VPC, so that the glue job running inside that VPC in that subnet will have access to Lake Formation APIs. Okay, so this is also very important, especially if you are working with a glue job which is running with a VPC. Now, time for a demo. I have two demos today actually, and in the first demo, I'm going to basically use Lake Formation API, where I'm going to read data from two different locations in a Sage, and I'm going to use SageMaker Notebook in this case because I want to run code line by line and show you the outcome. And then, so I'm going to read data from these two locations, and then I'm going to write to basically I'm writing to two S3 locations, and then I'm also cataloging, updating their data catalog. So that's the one thing I'm going to do using the Lake Formation API. And in another demo, what I'm going to do is that I'm going to create a glue job which will read data from an RDS table and will write it to S3 bucket and update the glue catalog under a single transaction. So these are the two demos I'm going to show you. And whatever code I have written for these two demos, I have provided the code in the description, link for those code in the description box below, and you can simply use it and run this test on your own to practice about it. So let's jump onto the demo. So there we go on the AWS console. I have so many things to show you here, but let's go to the Lake Formation first. So in the Lake Formation, what I have done is that I have created a database. And this database actually is a database which simply follows Lake Formation based security. So I have made sure that I have tick this checkbox off. That means it's not using IAM based security, but it is using Lake Formation based security. Now in this database, I have created a couple of tables. So these two tables actually are created using crawler, and basically they are fetching data from a PostgreSQL database. And this I'm going to use as a source in my second demo. And then I have created two govern tables. So this is one govern table, customers underscore govern, and second is employees underscore govern. And you can see here it says governance enabled. That means these are the govern table. And these are the locations of the govern table. So S3 Dojo data set customers and S3 Dojo data sets employees. These are the S3 location where these govern tables are created. Now, as I told you that if you are using a govern table, you can use only with the S3 bucket, and then that S3 bucket should be registered as a data lake location. So it is very important. So quickly, just to verify that, I have already created data lake location, S3 Dojo dataset customer, S3 Dojo dataset employees, and these are the roles which I have created with the permission I talked about. So these roles have the same permission I talked about in my presentation, and these roles actually are used to manage this data location for accessing the data and also for managing the transaction. So these two locations are already registered here. And here is my table. Now let's see how do I create a govern table. Okay, I will probably not create the full table, but let me show you a demo. Creating the table you can do only manual. So let's say I'm creating a new govern table. So I simply go to table, then I call it say dummy table. I can provide my database where to create this table. Then I can provide, of course, description. And then this is one additional thing you have to do for the govern table. You have to check this box which says enable govern data access and management for this table. And by checking this, you're saying that this is a govern table. Then you simply provide the S3 location where data is stored. So I'm suppose saying my location is, come on, okay, let's say this one. Okay. And then I come down and say what is my data format. Suppose say I want to use Parquet as a format, and then here you create the schema. So you can either upload the schema using a JSON document, or you can create it manually. So I can simply say, okay, this is my first column is a first name, which is of a string type, and then I have got my second column, which is my last name, and add, and then I simply say this is my age, which is of big integer, suppose, and add. So you can create a schema like this. So and then you submit and then your govern table is created. So this is how you create a govern table. It's not different from how you used to create table earlier manually. Only thing is that you have to make sure that you have actually clicked on this particular checkbox here, and when you do so, this table becomes a governed table. It is managed by AWS for performance optimization and data compaction and also transactional support. So this is my lake formation thing. So now what I have done here is that, so these are my two destinations. So one is your Dojo data set customers, which is a location for my customers govern table. Right now it is empty. And then this is my Dojo dataset employees location, which is a location for my employees govern table. Now I'm fetching as a source, I'm fetching data from these in Dojo dataset. I created a source as one of the folder, and there I've created two customers and employees table. I'm simply fetching data from there. And then I'm trying to write it to the destination location, which are your customers and employees location. So to do so, what I have done here is that I'm using a SageMaker notebook. And this SageMaker notebook actually is running under a role called Dojo SageMaker role. And why I'm showing you this here, because this role needs to have permission on your tables. Otherwise, it will not able to perform any transaction. So if I go to my lake formation, and if I go to my data lake permissions, and if I try to filter my permissions here and say my principal is actually Dojo SageMaker role. If you look at these permissions, basically what this role has permission is that it has permissions on both customers govern and employees govern table, and in fact I've given all the permissions here. I've given the full access to these two tables over here in this role. Okay, so keep this in mind that if I'm writing data to govern table and if I don't have permission to write to govern table, I cannot do that. And that's why I showed you that I'm using a SageMaker role with a notebook, but then that role I have given permission in my lake formation to my govern table so that that role can perform the operations. Okay, so here was my SageMaker role, and then let's jump to my code. So here I've already created my code, so let me open that code. So there we go. So we have already created the code over here, and I can run this code one by one and show you the output. So first I'm creating, and this code I'm providing also in the in a link in a description box, so you can play this by yourself. So you can see here, this is my, I'm creating a Boto client. Then I have few things I have configured just to save time. So I have got my source folder, two source folders. So I'm reading data from two source folder. So these are two source folder I'm reading data from. This is the bucket where the source folders are created. Then I've got two objects. These are two objects I'm reading from my source folder. These are my destination folders. So reading from two source folders, writing to two destination folders. And for these two destination folders, I have created a govern table on top of that. This is my account number. This is my database. These are two tables. These are two tables I'm writing data to, table 1 and table 2. So employees govern goes to employees folder, and then customers govern goes to this customers folder. Then I have also copied the e tags, entity tags, and size. So how do I get that information? So for instance, if I go to my source customers, and if I open one of my objects here, I can see my entity tag, and I can see my entity tag, and I can see my size as well. So these two I have also simply copied it just for demo purpose. So I have copied these two things. Now, so let's, so this is my, I have put every parameter at one place so that I don't need to, it's at one place and easy to configure. I'm simply running this particular cell. Okay, successful. Now I'm starting a transaction which is performing read and write operation both. It's the same code I showed you there. Now I am starting my transaction and making note of my transaction ID. So sorry, I started transaction over here. I'm just making note of my transaction ID over here. I'm printing over here the transaction ID. Now what I'm doing is I am performing two copy operations. So some source folder 1, object 1, I'm simply copying to destination folder 1 and object 1. And source folder 2, object 2, I'm copying to destination folder 2, object 2. So in this cell, what I'm doing, I'm simply reading data from my source folder and writing to my destination folder. Okay, so simple. So my ETL is done. I have read from the source. Basically, I'm not doing any transformation here, but I'm simply writing it to destination. And then I am marking each of these things as for delete object on cancellation. So what I'm saying here is that I'm marking both locations, destination 1, object 1, and destination 2, object 1, which I just created in the previous step. I'm simply saying these objects should be deleted if my transaction fails, and this is my transaction ID. If this transaction ID fails, you simply delete these two objects. Okay, so I'm doing it 2 times because I have got two different objects. I think I could have put these two here because it supports array, so I could have put these two together, but I run it separately. So successfully mark my object for deletion. Now what I'm doing here is I'm updating my objects. Now so one thing I want to show you here. If I go to my Dojo dataset customers, and if I refresh my folder here, you can see my data has been written over here. So data is already written to the destination because I simply run the copy command in one of the cells. Then if I refresh simply employees folder, my data is already written to the employees folder. So when I'm running this code and I run this particular code over here, data is already written to the destination. But then I am bundling this whole operation under transaction. So first I said that these objects which is already written to destination, if my transaction fails, simply delete those things because I want to run them under one transaction. And then I'm simply updating the object table. So here is my destination folder, destination object. I'm adding this object for this table and this database. So I'm simply updating the table object. I'm saying that, hey, table 1, you have got a new object added to you. And this also I'm doing under transaction because I want everything to roll back, even table updates to be rolled back if my transaction fails. And I'm doing it 2 times. One time I'm doing for destination 1 object 1 and second time for destination 2 object 2, table 2 and table 1. For both tables I am doing it. So let's run it, and it has also updated the table object. Now here comes the moment of truth, guys. So if I simply call a commit transaction, then whatever I did right now, the updating the table, updating the data object, everything will be committed. It will be a happy path, works fine. But if I cancel the transaction, then it's going to roll back everything. So what I'm going to do, just for this demo purpose, I'm going to cancel transaction. But this code I'm giving to you, and you can of course change the parameters and you can run by your own. So what I'm going to do, I'm going to cancel the transaction and then I show you the behavior. So if I simply cancel the transaction, and then I'm going to see the description of the transaction. And if I see the description of the transaction, it shows that it has been aborted. Now, moment of truth. These 2 files are already written. Would they roll back? So let's see. Let's refresh it. Let's give it a couple of seconds. And if they don't betray me this time, they should roll back. So let's give a couple of seconds. I will wait for a couple of more seconds. Okay, come on. Here we go. See, customers gone. So file was there, now it's not there anymore. Similarly, if I go to employees, file is there, refresh it, it should not be there anymore, or it should go anytime now. Okay, so okay, it's gone. And if I come over here, come on. Okay, probably have to wait for some more time. Yeah, here we go. Employees also, the data is gone. So you can see here, it showed the transactional behavior. So I read the data from the source, returned to the destination, then I marked that object under transaction, then I updated the data table catalog, I marked that under transaction, and in the last, I purposely said that I want to cancel the transaction so that the whole data written should automatically roll back. So that I showed you as a demo 1. And of course, I'm going to give this code to you, and you can run this code by your own to see, to play with various combination. I showed you, I write 2 objects, and both objects roll back automatically the moment I said that I want to cancel the transaction. Had I called commit transaction, they both would have committed and stayed over there. But now they have cancelled. So that was the demo number 1. Now demo number 2 is where I'm going to read data from an RDS database. Then I'm going to perform some transformation, and then I'm going to write that data to the location. So what I'm going to do here is that if I go to my Lake Formation and go to my tables, I am going to read data from my SRC Postgres public customers. This is an RDS database, Postgres RDS database. I'm going to read data from here. and then I'm going to write this data to this customer's location, and then I'm going to simply run it under transaction. Okay. And this I will use this time PySpark glue job. So what I'm going to do, that I'm going to the glue here, and then I'm going to my glue jobs location. Let's add a new glue job. Okay. Now, so I'm trying to say here dojo transact job, and I'm running this glue job with dojo glue job role. Now, let's see what permission this dojo glue job has got here. So let's go to my data lake permission and simply say my principal is dojo glue job role, and this has got quite some permission. So this dojo glue role can actually read data from my customers and employees table, and it can also write data to my employees and employees governed and customers governed tables. So it has got all the permission. Again, guys, I told you, whatever roles and you use, you have to give certain IAM level permission, like I showed you in my presentation, but you have to come back to Lake Formation and give permission here as well for the data access they want. So in this case, I want to read from my customers, I want to write to my customers governed, and that permission I have given to this particular role. Now, coming back to my glue, so I select my dojo glue role. Now this is Spark. I want to use Spark, PySpark. I can use actually latest version. I can go and use the version 3.0 if Spark 3.0 Python 3. So I can use the latest version. Why not? And then I want to say that I want to write a new script which I am writing, and the location is basically in my dojo data set. I have got a script location. Simply store the script there. Okay, this is my script location. Then I simply say next. Now, since I'm reading from RDS database, I need to use RDS connection. So I'm simply going to use this RDS connection, which I have configured in, it's a data glue data connection, which I have configured in glue job already. And I have used this for cataloging my tables from my RDS database. Then I simply save job and edit script. So now what I'm going to do is that I'm going to add the script, and I have already created a script. Actually, I'm going to simply copy paste. It's the same script I showed you in my presentation, but let me write it here, copy paste here. So here we go, and let me save it first. So you can see here, I am simply in this glue job, I'm simply importing some libraries. Then I'm starting my glue. I'm like starting my glue context and everything. Then my database is DojoDB. My table is src Postgres public customers table. I'm starting the transaction. Then I am reading data from my data source, which is database and this table over here. I'm reading data from there into this data frame. Actually, I'm not performing any kind of, you can say, transformation on this data at this point of time. This is my destination location, Dojo dataset customers. And then I'm creating a sink, simply providing S3 as the connection type. This is my destination location, enable data upload, run under this particular transaction. So I started my transaction here. I'm saying run under this particular transaction. And then simply call delete object on cancellation. And then in this case, I'm saying this is my Parquet used glue Parquet formation format, because that's how I have configured my catalog using Parquet format. This is my destination location, my database, and my table name is customers governed. And then I'm simply saying that, hey, write the frame and then commit it. If any error comes, simply cancel it. In this case, I'm not going to raise any error. I simply want to see a happy transaction happening. So I'm going to save it, and then I'm going to run this particular job. So if I go to my customers folder over here, right now there is no data written over here. Now what I'm going to do is that I'm going to run this particular job. It will take roughly a minute or so, and it should write my data at the destination, because my code is right, and there's no error in that, hopefully. And it should commit my transaction. So let's wait for it to finish writing the transaction. Okay, so you can see here that my job has succeeded, and it took roughly 1 minute 15 seconds to finish everything, and it has written my data. So this particular script, which was actually doing the same thing like any normal job, but now this was using transaction. So it started transaction, and then it wrote my data under a transaction, and finally it confirmed the right operation using a commit transaction over here. Basically, this transactional job has written my data at the destination, and if I refresh my customers folder over here, I can see 5 different files written over here, because there were 5 rows in my table, and that those 5 rows, each row has been configured as has been created as a file in this particular folder. So that was the example how you can write a glue job with a transactional behavior to read data from the source and then write to the destination. Had there been any error, of course, this job would have raised this cancel transaction. In that case, both writing of the data as well as the catalog table update, both operation would have rolled back. So that was all for today, guys. I know it was a long video, but hope you understand the concept of handling transactions in ETL glue job using governed table. And if you like the video, please click on the like button, and please subscribe to my channel. If you have any feedback, or if you have request for a new content, or if I made some mistake which you want to correct, please feel free to provide your feedback in the comment section. I always look forward to your feedback to improve my content. And I promise to come back again in a week's time with another exciting topic and tutorial. In the meantime, stay safe and have a nice day. Bye-bye.